Hello everybody. Today we'll have another look at an Astro-COLIBRI feature, and that is the information we provide for all of our events. This information contains at the one side data about the event itself, the most important parameters, but also an extensive set of links to external services. And I will show you what we can do with these. As introduction, I'll show you a set of slides with the main event information we provide and the driving ideas behind our implementation. At the end of the set of slides, you'll probably understand all these various links we show here, and then we'll dive into an online demonstration. What I'm talking about is the information box that you can see here in the web front end of Astro-COLIBRI, where we have the detailed information about each of the events. And I will show you now what information you can find there and how you can use that. The general concept for this information box is that we aim to provide the most important information for each event directly within the Astro-COLIBRI clients. And this is both the web front end and the smartphone applications. And of course, this information is different for each type of the event, each observatory, etc. So therefore, we adapt the information on an event-by-event basis. We, of course, also provide links to external databases and services to draw from the large knowledge base that is available to the community. But we always try to get access to the individual event. So we will not build a library of web links or bookmarks only pointing to the entry pages of these services. So for example, we point directly to the archives of the history of the event if there are several updates. We point to analysis results of various observatories for a transient event, for example, and we point to general purpose databases where you can find additional detailed information about each event. I'll show you a few examples in the following. The basic information of each event is shown directly in Astro-COLIBRI. This, of course, includes the name of the event, its coordinates in a different system with hours, minutes, and seconds, and the name of the observatory. And depending on the event itself, it might contain additional parameters that are important, like the false alarm rate, the energy, the astrophysical probability, for example, for a neutrino event. And of course, we add comments, like if a GRB has been detected also by the high energy instrument on the Fermi-Lat satellite, or a redshift has been measured. All of these parameters we show are ready to be copy and pasted, so you can use them directly for informing colleagues or scheduling follow-up observations. And if this is not enough, we also directly link to the full information that we have that is contained in the VO event information from the 4PySky database. Once we have selected a transient event, we can point to general purpose information on the web. This includes the well-known services like the Aladdin and ESA Sky All Sky View. We also provide a direct link to the Fermi-Lat All Sky Variability Analysis called FAVA, and a link to the SED Builder from the Space Science Data Center. We also provide a link to TOBE, which is the European Space Agency reference implementation of the IVOA access to the schedule of the main spaceborne observatories. And then we have a set of dedicated links that depend on the event and the nature of the event itself. These can point to the SIMBAD or NET databases, to the Transient Name Server TNS for FRBs and tidal disruption events, for example, and to the well-known archive of the gamma ray coordinates network for GRBs, neutrinos, or gravitational waves. Gravitational waves also have their own database called GraceDB, which is filled by Virgo and LIGO and Kagra and provide detailed information about detected gravitational wave events. For events detected by the SWIFT satellite, we also point directly to the online analysis tools and first results from the SWIFT BAT and the SWIFT XRT instruments. Now let's have a look how this works in practice. We are here on the Astro-COLIBRI website. I've selected one of the recent IceCube detected neutrino events. Now in this information box we are talking about today, you see here the link to the VO event information, as I mentioned, where you find all detailed parameters that have been published by the IceCube collaboration. The most important of these parameters, like the name, the coordinates, and of course the observatory, are given directly in this information box. As I mentioned, this also includes the false alarm rate, the probability for this event to be of astrophysical origin, and its energy. And then we have this set of links that I mentioned to the external services, which comprise the Aladdin, ESA Sky, the SSDC SED builder, the TOBE link to the visibility and schedule of satellites, and the FAVA R-Sky variability analysis. Then dedicated to this event, you get a link to the GCN notices, GCN-N, and the GCN-C points to the circulars that have been submitted for this particular event. If we select another event, for example, one of the recent GRBs detected by SWIFT, you see this display changes. You start with the same information, but then we have added a comment that this particular GRB has also been detected by Fermi-Lat, including the number of the GCN circular that announced that detection. This event also has a measured redshift, which we provide in this comment field. In addition to the links that I've shown earlier, we now can also point to a summary of information provided by the SWIFT satellite, where you find all the details again in a nice overview form for this particular burst. And we can point to the analysis results by the BAT and XRT instruments, where you find detailed light curves, spectra, etc. We of course also provide information about the known sources in the region of interest. So if you select one of these transient events and go to cone search, where we see the known sources or cataloged sources in that region of interest and within or just surrounding the uncertainty region of our transient, you can click on these and you get the relevant information for each of these sources. So you get, for example, in addition, a link to the TEFCAT catalog because this source is already detected at TeV energies. And again, you get direct linked, for example, also to the SIMBAT catalog with much more detailed information about these known and stable objects. All right, that's it for today. I hope I could show you the details we provide for all of our events and how helpful it can be to get this one point of entry to all the existing information in the various external databases. If your favorite link or favorite information is missing, please feel free to get in contact with us. We are happy to add it for you. See you next time. Bye.